In Part 5 of the Godot documentation, we are going to be making our first GD script. Please see the documentation for more information, but in this video, I'm going to walk you through my understanding of how to make the Godot icon turn in a circle. We are not going to use C# in this video, but you can find examples of how to use it in the documentation for this lesson. We feel it's likely that you already know how to program in it if you are electing to use it, but the concepts covered are the same. If you enjoy software educational content like this, we would appreciate it if you would like and subscribe to support the channel. It means a lot to us, as this can take a lot of work to put together. This video assumes that you already have programming knowledge. I will only touch on some of the concepts as we build the code. We will have a dedicated course on programming at a later date. We are going to start by creating a new project. You can call it whatever you want. I am going to call mine something like spinning icon. Next, we need to create a scene. There are a few ways that you can do this. You can click the other node button and click Sprite 2D. When you have the Sprite 2D, it doesn't tell us what it wants to render to the screen. To do that, we will need to add the Godot icon to the texture slot. You can click on the slot and click the load button to add it. Or just drag the icon into the slot. Godot is intuitive this way. But we actually didn't need to go through all of the trouble of doing it this way. Like I said, Godot is pretty intuitive. You could have just dragged the icon directly into the scene. The engine would have done all of that setup for you by automatically creating a Sprite 2D node and texture. Either way, we now have a scene and want to make it do something. If we click the little scroll-looking piece of paper icon here in the scene dock, we can at the same time create a script and attach it to our node that we have selected. You could have also right-clicked on the node and added a script. A new window will pop up when you do this. You can change all of this, but you see some requirements printed here. You have to meet them before you can do what you need to do. For our purposes, we can leave all of this alone. But we can change what the script will inherit, the name of the class that it will have, the template, whether or not it is a built-in script, and the path it will be saved at, if we want. Like I said, let's just leave all of this alone, as it will not help us to change any of this to make an icon move in circles. The documentation changes the template from node to object empty, but it doesn't really matter. All that does is change what methods are in the functions or in the load, so that you have to write them yourself. The script workspace should appear with your new sprite2d.gd file open. At the top of this script, we see extend sprite2d. In GD script, if you omit the line with the extends keyword, your class will implicitly extend refcounted, which Godot uses to manage your application's memory. We will talk about that in a later video. Let's talk about what extends means, as it can be confusing to someone just getting into programming. It took me a while to understand as well. Basically, every script in and of itself is a class, which you can think of as a thing or object, if that helps. Because of this principle, it can inherit methods and properties of the class it extends. In this case, a Sprite 2D, and everything that Sprite 2Ds inherit. For example, if we want to make the sprite bigger, we would need access to its scale. If we go to the ready function, which we will talk about in a moment, and type self.scale, we can assign a vector2 to the scale property of the parent or grandparent object that is inherited and change the size of the object. When you see this self, it means that it is referring to the game object itself that this script is attached to, since it is a class in and of itself and not referring to anybody else. You use this self when you explicitly want to do that. But in reality, we don't need to do that. Because, like we mentioned a moment ago, each script is implicitly a class already. Godot is intelligent enough to know that if you just leave the self off, most of the time it just understands that we are talking about ourself, being the object that this script is attached to, when we call scale. But let's just delete that for now. Let's talk about GD script syntax. Like in Python, we use snake case. This means that every word in a variable or method name is separated by an underscore, making our words into something like a snake. But you will find that in the inspector, you will find that Godot has title-cased variables, which makes them easier to read. You can hover over any property's name in the inspector to see a description and its identifier in code. Alright, let's build our quintessential Hello World script that literally every programmer builds when starting anything out. We are simply going to print Hello World to the output console and get an idea of the syntax. If we look on the screen, we see two methods are already defined for us. If we start writing code in the bodies of these methods, stuff will just kinda happen when we run the game. The reason for that is that when you have a game running, Godot is actually calling these methods for you without you needed to do anything special. You only need to define them, and the engine will handle the rest. These are called on every script that you write. You are actually overwriting logic in the game and adding your own when you program here. Don't worry about how that works for now. I just wanted you to understand that before we get into writing our own methods in a later video, where we have to call them ourselves. As that is another thing that really threw me off when I was getting started. Also, when you see these underscores, it means that the method is called by Godot. Let's just go to above underscore ready right here. We are going to define another method that Godot will call for us. You see, in underscore ready, this method is called when an object is loaded into a scene. We are going to define another method called underscore init. This method is called when an object is loaded into memory, which will always happen before a game object is loaded into a scene. Because logically it would have to. To write it, let's declare that we are writing a function with the func keyword. Then define what the function's name is, which is underscore init. This method, or function, will take no parameters, so just add open and close parenthesis. Don't forget your colon to close it up and declare that you are now writing in the body, and make sure you are tabbed in the line below this line to actually do that. Now type print, which is another built-in method in and of itself. Then open parentheses to specify that you are about to give the print method an argument, and type a string value of hello world and close it with a closing parenthesis. If we save and run this scene now with the script attached to the game object, we will see that immediately when the object is loaded into memory, in the output, we see that hello world is printed to the output. How cool is that? Now your turn. Write whatever you want in that argument instead of hello world, just for the heck of it. Alright, let's actually do some game development and make our guy turn in a circle. Let's add two member variables to the script. This means that the object that the script is attached to will get new properties. We can actually expose them in the editor with the @export keyword in front of them too. At the top of the script, but below our inheriting extends line, let's type export to expose it in the editor, and then var to declare that we are about to write a variable. Then we'll call it speed and give it a default value of 400. We will see what this means in a moment. Just hold on to that thought. Next, let's define an angular speed of pi. Godot actually understands what pi is, and it's built right in. Let's not expose this one, as pi is a constant and we have no reason to change it. Type var and then name the variable, which is angular underscore speed, and assign it to pi with the equals sign. Click the search help up here and type it in if you want to learn more. Also, Godot works in radians by default, but there are built-in methods and properties to convert them to degrees, if you need to. You could have written these variables anywhere in the script outside of the method bodies, and it would have had the same effect, but we typically like to write them at the top, as it makes our code cleaner and easier to read. Now that we have defined some variables, we want to move our icon around, so let's talk about the elephant in the room here. Underscore process. You see, the way that games work is that they draw everything to the screen one frame at a time. If you add these frames up and show them fast enough, you get the illusion of motion. This is sometimes referred to as a game loop, but that isn't quite right either, as a lot of things happen in a game loop. Underscore process is called by Godot on each frame. So for each frame that we want something to happen, we will write our logic here. The trouble is that computers with different CPU and GPUs can render things more or less faster than others. This is also known when quantified as FPS or frames per second, which we don't really want to vary from computer to computer. So it has a parameter called delta to combat the discrepancies. We will talk about how that works in a bit. Delta time confuses a lot of people, but it's not actually as complicated as you might think it is. We can talk about what delta means in a bit, Let's write our logic before we talk about boring math stuff. Inside of underscore process, remove the pass keyword, and let's get access to the parent object's rotation property. You could type self.rotation, or simply just rotation and get access to it. Next, we want to update it on each frame, so let's make it equal to itself plus the value of angular speed times the value of delta, which gets updated by the Godot engine on each frame auto-magically. The shorthand way to do that would not be to type rotation twice, but instead plus equals. Let's just run our script like this and see what happens. You will see that it just spins in place. Now let's move the icon around so that it isn't just spinning. To do this, we need a velocity. Still in the method, define a var and name it velocity, and then assign its value to a built-into Godot vector2 class. On that vector2, we will access its property called up, and then that's built-in method called rotated. We will pass in the value that we calculated right before we define this, which is the value of rotation at this point. But what if we want to control how fast it spins? Let's multiply this equation by the speed variable we defined earlier. And also, we expose this variable in the editor, so we can play with it there as well. Increase it or decrease it to make it spin faster. If you think about what is happening, on each frame, we are calculating how fast the icon should be moving as it is rotating. Don't think too hard about the math. Next, let's update the position of the icon on each frame. Get access to it by typing position, and then update itself plus the velocity, and don't forget to multiply it by the delta value to make it frame rate independent. Now let's play our scene and watch what happens. Alright, before we go, let's talk about how delta time works. Before the process method is called, Godot does some math to find out how long it took between when the last time the process method was called, and the current one that is being called to do all of its stuff that it has to do in the method body of it. Let's assume that we want our game to run at 30 FPS. That means for every 1 second that passes in real time, 30 frames should have passed. But computers are just running as fast as they can. You want that to happen, but it's a problem if you are looking for consistency across different computers. Let's say that we have a ball that we want to move to the right on the screen by 10 units of distance in 10 seconds. It doesn't really matter what that is in real-world terms, if it's feet or meters. We can cheat with math to get around how high or low of FPS our computers are running at. Let's say that Godot calculated that it took something crazy, like 1/10 of a second, between the last time process was called and the start of the current call. The delta value that gets passed in is just that, 1/10. Now, when we do our math on the current frame, we have to move the ball 1/10 of the distance to where we want to end up in 1 second, because that's how long it took in that time frame between the last call and now. Now this frame ends and we are on the third frame. Godot figures out how long it took between the second frame and now. This time it takes 1/2 of a second, because our computer is silly. We know where we want to end up, so then we will move half of the way there now from where we are at. We will then just repeat this process over and over until we get to our target location. And if you did the math, you will see that it's just changing how far we actually need to move on each frame to get there. Congrats. You did it. You're a true game dev now. If you enjoyed this content, please like the video and subscribe to the channel. And thanks for making it all the way through the video. Please join us in the next one. See you next time.